everybody. Okay, welcome to the next video of our Plexus training. Tonight I'm going to start by talking to you about one of the main products, one of the first products that Plexus launched. And so we're going to get into the nitty gritty here. We're going to start talking about products, which is what a lot of you I know signed up to do here. So tonight we're going to start with talking about Plexus Slim, aka the pink drink. A lot of you have heard of this product already. I have posted a ton about it on my personal page, and I talk about it often, even in my groups and stuff that I do. So Plexus Slim, the pink drink. So it comes in packages like this. The lighting is really terrible here, so I'm sorry about that. Two versions, okay? It comes in these packages, and inside of these is little stick packs. Basically, you open them up, and you dump it into a glass of water or a bottle of water, shake it up, stir it up, whatever, and it's a fruity drink full of nutrients, and you drink it probably 30 to 60 minutes before breakfast, ideally. Some people have medications that they have to take in the morning and can't do it at that time, so you can even take it, 30, 60 minutes before lunchtime or even dinner. Some people take both of them, one at each end of the day, and that helps too. So there's two versions. Hunger control. Again, the lighting is terrible. So there's hunger control, and then the other one is called Plexus Slim microbiome activating. Now, there are many similarities to these and a couple differences. I'm going to go over both of them with you, the similarities and the differences. But I'm going to start with the similarities. So on the Plexus packaging, it says that Plexus Slim helps support a healthy glucose metabolism. So what does that mean? What the heck is that, right? Okay, so glucose, healthy glucose metabolism. What is glucose? So glucose, as most of you probably already know, when you eat carbohydrates, your body breaks down the digestible ones into glucose, basically sugar. And that sugar, that glucose, it goes into the blood and your blood sugar levels rise, right? Now, glucose is a good thing. Glucose is fuel, is energy for the body. Glucose goes into your cells, and it's used to help the body do what it needs to do all day. So glucose for the body is like gasoline for your car. It's necessary. It's a good thing. The thing is, cells can't use glucose on their own. They need something called insulin. Now, insulin is, it's like a key that unlocks the door of the cell so that the glucose can get in there and be used by the cell for energy. So basically, no glucose or no insulin, no energy. So glucose just hangs out in the blood if the insulin does not do its thing to allow that to be used for energy. So basically, recap, eat carbohydrates, digest into glucose, blood sugar levels rise, pancreas makes insulin or sends insulin, those blood sugar levels fall because the insulin is shuffling it. It's going into the cells or wherever to be used for energy. Now, if you eat more carbohydrates than your cells need for energy at that time. Say you eat a big bagel, but you're just going to go sit and watch TV. So you don't really need tons of energy. So the excess leftover glucose that you have, insulin also then will help store that. And the way that it does that is it helps store that in the liver. The liver acts as like a storage facility, like a warehouse for excess glucose. It kind of packages it up. Insulin helps package it up in these bundles called glycogen. It's like granules, like boxes in a warehouse, okay? And it's stored there for later on when the body needs energy. If you were to need extra energy later on, but you hadn't eaten again, your body would have fuel waiting that it can utilize at that time. So the liver is kind of like a storage warehouse for excess glucose. But the problem is it's only so big. Like any other warehouse storage facility, it has a limited capacity. It can only store so much. So then what? So, say you have excess glucose still, even after the cells have used what they need and the liver has stored what it could. Then what? The liver actually will turn that glucose into fatty acids. It will then shuffle it through the bloodstream, and that fat will go to tissue. Okay, so and sometimes even the fat stays in the liver, and that's when some people develop what's called non-alcoholic fatty liver disease, and that's basically where there's too much fat in the liver. And this is how eating too much sugar, eating too many carbs can cause significant weight gain, because here's the thing. The body does not have a limited capacity when it comes to fat storage. The body can keep storing fat. So this is where the weight gain comes from eating carbs and sugar. The other problem is, weight gain isn't the only problem with glucose metabolism. You can develop what I call, when you eat too many carbs, it's like a roller coaster glucose metabolism, a roller coaster blood sugar levels. And what I mean by that is when you eat too many carbs, or specifically simple carbs, there's simple carbs and there's complex carbs. Simple carbs are sugars, white sugars, white breads, things that are really refined and processed. These types of things are digested very quickly. Okay, so they have a tendency to spike those blood sugar levels really high, really fast. Whereas complex carbohydrates, things that are closest to their natural form that still have fiber and protein, those are digested a little more slowly than simple carbs. But so when you eat the simple carbs or an excess of carbohydrates, it sends that, like I said, that blood sugar level high. Now, that signals the pancreas, like I said, to produce insulin and send insulin out to be used for shuttling into the cells or storage or whatever. The problem is the pancreas is not a very efficient organ, okay? Sometimes when it gets that red flag that there's so much glucose in the bloodstream, it sends out an abundance of insulin, and it can send out too much insulin to the point where it removes everything out of the blood into storage or wherever, and then the blood sugars fall too low. And what happens when it falls too low? A lot of things that are actually kind of dangerous to the body. One, not so dangerous, but it will trigger hunger. Okay, because what's happening is that it gets dangerously low, and it's a protective mechanism for your body, because your body, wants to hurry up and get that blood sugar level up, because you don't want to have coma or a seizure or these types of things. So it triggers hunger, it triggers eating. And so those cravings, what types of food are you going to crave then when your blood sugars are low? You're going to crave the types of food that are going to raise that blood sugar level high. So you're going to, and fast. So you're going to crave sugar. You're going to crave simple carbs. You're going to crave things that aren't always the healthiest. And so then you eat those things, takes it way back up again. The pancreas is like, oh my gosh, it's up again, sends out a boatload of insulin, and it's back down again. So here we have that roller coaster. And again and again and again, and you have the cravings. This can also cause, like fatigue, because when the blood sugars get low, you have fatigue, sometimes mood swings or sweating. But what else happens? So low blood sugars also will trigger a release of stress and adrenal hormones. Because when stress hormones come, okay, if you think of the flight or fight response, a lot of you have probably heard that. Fight or flight basically means when a threat is present or some stressor is present, you have the option. You either have to, like if an intruder comes into your house, you either have to fight the intruder or you have to flight, run for the hills away from the intruder. So when that type of stress or threat is present, these stress hormones are to help you in that flight or fight situation. And you need fuel for that. So the release of stress hormones raises blood sugar because the body is expecting you to have to deal with some type of physical response. So the release of stress hormones pushes blood sugar levels back up. Now, you might be thinking, oh, well, that's a great thing if my blood sugars are low. The problem is these are stress hormones. And so a lot of times what accompanies these stress hormones are things like rapid heart rate, heart palpitations, sweating, nervousness, tremors, feelings of anxiety or panic, like things that you would experience if you had an intruder in your house. You know, and that's not all. So cortisol, the stress hormone that's primarily in the flight or fight situation, it has the ability to store fat around the abdomen. Okay, so it does this as it's a good thing. It's actually a good thing. It's called visceral fat, but it's a protective mechanism for the body. So you think, okay, an intruder's in my house, or whatever the stress is or the threat is to the body. This cortisol is forming fat around the abdomen because it's trying to create a cushion around your vital organs. So it's trying to protect you from some type of physical threat that might harm the body. So it's trying to save your life, essentially. And this fat, visceral fat, is very different from just, you know, fat that's on your thighs or your hips or anything like that. This fat, visceral fat, actually is thick and it encases your organs to protect them, like I said. The problem is this fat is very hard to get rid of because it is a protective mechanism for the body. So when you have visceral fat and cortisol response, and you're going to the gym trying to work off this abdominal fat, your body's going to work off every other type of fat first before it touches visceral fat, because visceral fat is protective. In fact, studies have shown that in a lot of instances, your body can take fat and deposit it around organs and increase visceral fat. That's one of the jobs of cortisol. So it can actually, cortisol can take fat from your butt and put it in your belly, basically, as a means to try and protect you. Not very fun, I get it. It can also, your body will start to break down muscle tissue, even tendons, before it will touch visceral fat. So it's not uncommon you see people with bellies. Okay, they have fat in the belly, but they have really skinny legs. And sometimes they start to have like sprained ankles or knee problems or something. And this is a lot of times a very common thing that happens with too much cortisol, a lot of stress, blood sugar issues. So it's a dangerous fat though, because like I said, it's encasing your organs and it's fat. So it does increase your risk of heart disease. And it's not a healthy kind of fat, even though it is a protective fat. It's kind of a catch-22. But you see where I'm going with that. So it creates this like domino effect. But back to healthy glucose metabolism, you know, you have then over time this roller coaster of high blood sugars, lots of insulin, low blood sugars. And over time, what can happen is your cells kind of stop listening. Insulin becomes like the boy who cried wolf. So your body is sending this boatload of insulin every time your sugars are super high. And after a while, your cells are like, yeah, we've heard this before. You know, we don't need all this glucose. We're not listening. So your cells start to ignore the signal of insulin. And this is a state what's known as insulin resistance, where insulin is there, it's shouting, hey, open up. And cells are like, yeah, we've heard this before, keep moving. What happens is then the pancreas says, okay, the cells aren't listening. So it's the mindset is, well, we're going to make more insulin, send more out, and the more numbers we send, the louder it'll be, I guess. So the pancreas works overtime, extra hard, sending more and more insulin to try and get those cells to listen and respond. The problem is over time, the pancreas is overworking and it becomes worn out. It becomes tired and it becomes less and less able to keep up with the demands and the needs that the body has to make insulin. So it slows insulin production because it's being worn out. When that happens, that blood sugar then is left in the bloodstream to raise and to become high. And like I said before, no insulin, no energy, no lowering of the blood sugar. That then can lead to the state which we know as type 2 diabetes. Now, that's different from type 1 diabetes, which is an autoimmune disease where the immune system mistakenly attacks pancreatic cells that make insulin, and that's a totally different situation. Type 2 diabetes is usually the wear and tear of the pancreatic cells that make insulin. They're overworked. But diabetes is like the thing that everybody is familiar with when it comes to blood sugars or glucose metabolism. It's like the poster child, if you will, for glucose metabolism issues. So sometimes people think, well, I don't have blood sugar issues because, blood sugar issues, that's diabetes. But in reality, diabetes is like the final straw. Diabetes is like the last domino in a whole spectrum, a whole line of other dominoes. So, somebody might not have diabetes, okay, that last domino, but they might have any number of the issues that are preceding it, meaning maybe they have hypoglycemia, insulin resistance, just erratic roller coaster blood sugars. Maybe they're experiencing just extreme fatigue, mood swings, stress issues, adrenal issues, whatever the case may be. There are any number of dominoes that lead up to that poster child for glucose issues. So this is kind of a very wide-ranging topic, I guess you could say, when it comes to what is a healthy glucose metabolism versus an unhealthy glucose metabolism. Also, it's not just your body, okay, that uses glucose for energy. A lot of times we think of energy, we think of being able to go and do, and you think of the body, but the brain actually uses glucose too, and it uses a substantial amount of glucose. The brain it's so rich in nerve cells that it uses, it's the most energy demanding organ of the body, and it uses like 50% of the body's glucose at a state of rest. So it's an energy hog, okay? The brain needs glucose. However, brain cells can also become insulin resistant, okay? And when that happens, a lot of times brain cells can die. So it's not at all surprising that a lot of medical experts nowadays are starting to refer to Alzheimer's disease as type 3 diabetes. And this is why, because of the abnormal glucose metabolism or unhealthy glucose metabolism in the brain. And, the extreme case for this, when it comes to the brain not being able to utilize glucose properly, like I said before, seizures, coma, things like that. But there are more common symptoms: memory fog, memory issues, poor attention, learning issues. These are all things that can be a result of inefficiently utilizing glucose. So again, the seizures, coma, whatever, that would be the last domino, but there are a slew of other things that can precede that on this spectrum. So poor glucose metabolism, unhealthy glucose metabolism, it affects so many things, or it's connected to so many different things, from weight, energy, like I said, non-alcoholic fatty liver disease, brain function. It even affects, it'll increase your risk of heart disease, stroke, so many different things. So when we talk about glucose metabolism, it's not just diabetes. It's not just blood sugar, simply blood sugar. Blood sugar is so intricately related to many other areas of the body. So that's why I wanted to be so